Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about differentiation. Now the question that I've chosen to go through here is 2016 Paper 1 Question 7 Part A. In this question we're told that air is pumped into a spherical exercise ball at a rate of 250 centimeters cubed per second. And we're asked to find the rate at which the radius is increasing when the radius is 20 centimeters, and give your answer in terms of pi. So the key word or the buzzword in this question is rate. The question says the rate at which something is changing is differentiation. So the air is pumped into the spherical exercise ball at a rate of 250 centimeters cubed per second, which means that this is a rate, which means that 250 is a derivative. You have to figure out which derivative it is. The easiest way to do that is just focus in on the units. The units are centimeters cubed per second. Centimeters cubed, what's measured in centimeters cubed? Well, clearly volume is measured in centimeters cubed. And what's measured in seconds is clearly time. So I know this is volume over time. So the rate at which the volume is increasing relative to time is 250 centimeters cubed per second. So in other words, I can say that dv dt is equal to 250. The rate at which the volume is changing relative to time is 250. So I think always focus in on your units, because in these questions the units is often a giveaway. I've been asked to find the rate at which the radius is increasing. Okay, so clearly that's the or. So you know it's definitely the rate at which the radius is increasing when the radius is 20 centimeters. So it's a bit ambiguous what you're getting the rate relative to. If it said find the rate at which the radius is increasing relative to area, then clearly it's the or dA, the radius changing relative to area. But it just said find the rate at which the radius is increasing, and it didn't say what it's relative to. So you should recognize that if it doesn't specify what it's relative to, you can assume it's relative to time, because everything is relative to time. So the rate at which the radius is increasing is the or dt. And in order to find the or dt, I'm clearly going to use dv dt. Okay, so I have a dt on the bottom now, but I need to multiply this derivative by another derivative. And I clearly want to have a dor on the top. Okay, so I want to be left with just the or dt. So I have a dor on the top and a dt on the bottom. So that means if I have a dv on the top here, I also want to have a dv on the bottom here. Clearly, if I multiply dv dt by dor dv, I should be left with dor dt. Okay, so I already know what my dv dt is, so I'm happy enough. The key to this question is I now need to find dor dv, the rate at which the radius is changing relative to the volume. So it told me it's a spherical exercise ball, which means that I'm dealing with a sphere. So if you go to your maths tables, you'll see that the volume of a sphere is 4 over 3 pi r cubed. And the fact that I know this, I'll be able to find dv dor, or the rate at which the volume changes relative to the radius. So all I want to do here is I want to differentiate. So in order to get dv dor, I just need to differentiate. Remember, when I differentiate, I bring the power in front. So 3 multiplied by 4 over 3 is just 4 pi. So remember, pi is just a number, so pi is not a variable in this scenario. 3 multiplied by 4 over 3 pi is just 4 pi. And then I decrease the power by 1. So rather than or to the power 3, it's now or to the power 2. So I know dv dor is 4 pi r squared. But I'm not actually interested in dv dor because I need dor dv. Or in other words, I need the reciprocal of this. So you should view dv dor as 4 pi r squared over 1, which means if I get the reciprocal, or in other words, if I just flip the fractions, that means that dor dv is 1 over 4 pi r squared. Which means I'm now going to be able to sub into my equation here, and I'm going to be able to get my dor dt. So dor dt, the rate at which the radius is changing, is dv dt, which is 250, multiplied by dor dv, which is 1 over 4 pi r squared. Now notice the question asked me to find dor dt when the radius is 20 centimeters, which means I can just sub in for my radius. So that means I have 250 on the top, and on the bottom I have 4 multiplied by pi multiplied by 20 to be squared. And now I can just plug all of this into my calculator because it asked me to get it in terms of pi. So if you plug all this into your calculator, you get 5 over 32 pi. Now again, remember I said units are very important, so always consider what should your units be. I found the dt, the rate at which the radius is changing relative to time. If the volume was measured in centimeters cubed, then clearly the radius is measured in centimeters. And I know that the time was measured in seconds, which means that this is measured in, that time is still going to be measured in seconds. Which means the dt, the units for the dt will be centimeters per second. The rate at which the radius is changing is 5 over 32 pi centimeters per second. And that's my final answer for this one. In A part 2 of this question, we're asked to find the rate at which the surface area of the ball is increasing when the radius is 20 centimeters. So make sure you're aware that just when they tell me the radius is 20 centimeters, they're telling me I can use my previous answer. I know that when the radius is 20 centimeters, the dt is 5 over 32 pi. So the chances are I'm going to use this in order to find the rate at which the surface area is increasing. Remember, the rate at which the surface area is increasing is the dt. The rate the area changes relative to time. And in order to find the dt, well, let's assume that we need to use the dt. Okay, that allows me to have a dt on the bottom, and now I'm going to multiply that derivative by another derivative. And I know that it's on one of them I need to have a dA on the top. So clearly I need a dA on the top. And when I multiply these by each other, I want them to give me dA dt. Which means that if I have a dr on the top here, I want to also have a dr on the bottom here. So if I multiply dr dt by dA dr, I'll be left with dA dt. So I already know what dr dt is, so I'm happy enough. The key is I need to find dA dr, the rate at which the area is increasing relative to radius. So remember, we're dealing with a spherical exercise ball. So if you go to your maths tables, I know that the area of a sphere is equal to 4 pi r squared. Which means if I know what the area is relative to the radius, I can differentiate to find my dA dr. So if a equals 4 pi r squared, then that means that the a dr is equal to, again I'm differentiating, so I bring my power in front. 2 multiplied by 4 pi is 8 pi, and then the power decreases by 1, so it's 8 pi r to the power of 1, or just 8 pi r. So that means now I'm going to be able to find my dA dt. I know that the dr dt is 5 over 32 pi. So the dr dt is 5 over 32 pi, while the a dr is 8 pi r. Okay, so I have a pi on the bottom of my fraction here, and I have a pi on the top. And I know I want to find the a dt when the radius is 20 centimeters, which means that instead of r, I can sub in 20. Which means that means to find the rate at which the surface area is increasing, my top line is just 5 multiplied by 8 multiplied by the radius, which is 20, and it's all of that divided by 32. Again, I can just plug all those into my calculator, and in this case, if you plug all this into your calculator, you get 25. So the rate at which the surface area is increasing relative to time is 25. But again, we need to ask ourselves, what units do we use? So I know the radius was measured in centimeters, the volume was measured in centimeters cubed, which means clearly the area must be measured in centimeters squared. And I know that the time is measured in seconds. So that means my dA dt is 25 centimeters squared per second. So my final answer for A part 2 is this. So I hope this video made sense. Again, I think a lot of students really struggle with these questions. The key is that you can come up with this. If you can follow how we're coming up with this at the start, the rest of the question is relatively straightforward differentiation. So just make sure, maybe if you're struggling with these ones, maybe highlight that. Listen to what I said about this a couple of times and just make sure you're clear on what I'm doing there. Again, if you're still struggling, then just let me know in class or send me an email and I'll try and clarify it a little bit for you.